So we're going to go over standard deviation. Now, it's a rather large formula with a lot of symbols that you may not recognize right now, but we'll talk about them again. The S stands for the standard deviation. So standard deviation is equal to, this symbol is the square root. Okay? So we're finding the square root of all this information under here. Okay? N is the number of data, so the number of terms in the data. Well, in this case, all of our data is down here. This is all of our data. If you recall, we did box plots with this exact same question. So we already know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, 8, 9, 10, 11, 12. 12 pieces of data. So in other words, our n in this question will be equal to 12. Okay, that's the number of pieces of data. Now if you remember, another thing we looked at is this x bar here. That x bar is the mean or average. Okay, and we talked about how to find that. What we need to do to find our x bar, because it is important, is we add up all of the data. So the way they represent it is x1 plus x2 plus dot 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 plus xn divided by the value of n. So what is n? N is, again, the number of terms. And when they talk about x1, what they mean is just the first piece of data. Well, x1 would be 110. x2 would be 113. And then xn, in this case, we already know that n goes all the way to 12. So that would be x12, the 12th piece of data. So what they're saying is we add all of the data up, and then we subtract, or we divide by the number of terms there are, which is simple. That's average. It's the exact same idea as average. So do you have the answer from this one? Because we've done it once before. If not, we'll do it. I'll add them up in the meantime.
Yes, it's 1523 over 12.
Okay, so the actual, what does it actually become though? It says 126.9. Perfect.
Oh, yeah.
Okay, so 126.9 is our mean. So that's very important because if you notice in this standard deviation formula, we have to take each piece of data. There's our x1, x2, and xn again. They're talking about every single one of these pieces of data. We're going to subtract from our mean. Well, this is our mean value. Then whatever that difference is, we're going to square it. So we're going to do this 12 times. Then we're going to add all of this information together, divided by n minus 1, which is 12 minus 1. And then when we get that, we're going to square root. So there's a lot of work to standard deviation.
Wow.
Okay, so what we're going to do is I'm actually going to rewrite all those numbers there in a row. Okay, and this is how we're going to do it. So we have 110, great, 113,
116,
116,
118,
yep,
120,
yep,
122,
yep,
124, 126, 132, 134,
give me a sec, 134.
144, and 164.
Excellent. So this is all of our data. Okay, these are all of our x's. Remember, to find standard deviation, we're going to subtract from x bar. Well, x bar is the exact same value every time, so we're going to subtract from 126.91 every single time. Okay?
Okay.
Now this is a tedious task.
Why don't you just go to
Excel? You can always go to Excel and do it. Yeah. So you're right. I'm just going to quotation this all the way down. Okay. So we actually have to find out what this is, what the difference of these are going to be. So you want to get your calculator out and we'll kind of go through these together here. What we'll do is we'll do the subtracting and we'll add that to the second part of the video. So we'll pause it. Okay. So we quickly went through this and we got all of our data. We subtracted all of these and these are all the values. But we're not done. Okay. That's just this bracket part here.
Right.
That's our data, subtract our mean. We still got to square all these values. So we'll kind of do this in green here. So what we have to do next is we have to do our data minus the mean squared. So we have to square all these values. So what are these values squared? And we're going to pause again and get all that information. Okay, so what we just did there is we took each of these values and squared them. So just as an example, so you can see what we've done, like we just did, I'll do the second one. We did 13.91, the negative value, and we square it, 193,481, right? And that's exactly what this value was here. Okay. Now, to jump back up again, remember it said it wants us to add all of these values together. Okay? So we actually got to get the sum of all of those. So what we're going to do is I'm just going to draw a little line at the bottom of this. And in our calculators again, we're going to add all of these values, okay? So big addition sign. And we're going to get a number underneath, which we'll do, I guess, in purple. And again, we'll pause for this because this is a little tedious. Okay, so finally, we've gotten this amount. We summed everything and got this. Now, this is technically known as your variance, okay? Variance. I think that's how you spell it. That's the variance, okay? In other words, what it is a variance is usually your standard deviation squared. In other words, to find the standard deviation of this, so standard deviation, we have to find the square root of this thing, okay? So we're going to square root that value. I can always do that too. So let's go 2502.9172, square root it. 50.029. Okay? So when we square root that, we get 50.029 or 92?
29.
29? Great. Okay. So that is our standard deviation, 50. What does that even mean, standard deviation 50 of something? Okay? So we finally solved it. A very long process to do all of that, eh? Especially the more data you have. That's why working with like Excel sheets or cells are a lot easier. So let's talk about what the standard deviation is in comparison. Remember, we need to recall this mean. Okay, if this is a normally distributed information, so this is normal distribution, they've probably shown you something similar to this. It looks like a bell curve like that. Okay, when you square root it?
Second that one, right? And then you plug it in.
No, you did times pi. This is fine. That's right. I'll show you that in a minute. So, a normal distribution, what it is all the information is around the mean. And in our case, that's our x bar. Well, x bar happened to be 126. Whoops. 126 point, what does it say on that sheet?
0.91.
91. Okay. And our standard deviation, that's really important. Standard deviation is going to let us know how much information is around the mean. So when we're going to find data. So let's say we're talking about one standard deviation both ways. Okay? This would be x bar plus s, and this would be x bar minus s. That's what these values are going to be. So we're going to add our standard deviation to our 126.9. Okay? So let's bring this guy up. 126.91 plus, we're just going to round it to 50. It's pretty much 50, okay? So plus 50, 176.91. So 176.91. And then when we subtract it from that value, I'm just going to, 126.91, we'll subtract 50 from it, 76.91. That makes sense. 76.91. So, one standard deviation both ways would take us to these numbers. And what that is underneath this curve, when you're looking for data, 68% of all of the data you look for will be within one standard deviation of our mean. Okay? So let's kind of zoom out and get a bigger picture here. What does that mean? Well, remember our highest point was 176, right? 176, that's our highest for standard deviation. Our highest value was 164. And the standard deviation below was 76, where our lowest piece of data was 110. So if we look at this, we zoom in again, all of our data fell within this range. Okay, everything was within here. The highest piece of data that we received was 164, which is probably around here, right? Because this is the mean right in the middle, 126. And the lowest piece of data we had was like at 110. Okay, something like that. So all of that fell within one standard deviation. That's 68% of all data will fall within there. Now this is going a little further from what you guys have talked about. Okay, 2 standard deviations. So here's a second. 2 standard deviations. Well, we got to add 50 again. Okay, we'll add 50 to this value again. 176.91 plus 50. 22691. Okay, so that's 226.91. This is 2 standard deviations. So this is x bar plus 2s, and this amount is x bar to the mean minus 2s. Well, we'll subtract that from 76. So that's going to give us 26.91. And what's going to happen here, okay, I'll do this in yellow and kind of go over all of that. Within that, that's 95% of all data will fall within 2 standard deviations. So all of our 95% of all the data we get will fall between 226 and 26.91 of all the pieces we pull out, right? And then the 3rd standard deviation, which you barely ever use when it comes to business stuff, will encompass 99% of all information, okay? So 3 standard deviations, so this is 3 SDs, this is 2 SDs, and this was 1 SD. And you do it both ways. All right, SD and 3 SD. Well, that's going to be 99% of all info. All the data we pull out will fall within there. So no matter what we're pulling, it'll always fall in there. And that makes sense because if we subtract 50 from this, we're going to get a negative value. So highly unlikely we get negative values. And this positive value is going to be 276.91. That's extremely far from the average. So it makes sense. Almost all of data will fall within that. So that's what standard deviations are. We're talking about being at the middle, the mean, and figuring out a range. Well, we add the deviation to the mean to get our 1 standard deviation, and we subtract it to get our low end of 1 standard deviation. And we figure out that when we're pulling data out, 68% will fall within 1 deviation from the mean. And if we looked, all of our information fell in there, which makes a lot of sense. Most of our information fell within that 1 deviation. And then we go farther into it, which you're going to get much more into these standard deviations of normal distributions later in stats. But that's what standard deviation means. It's how far from the mean left and right our data is and how much of the data will fall within there. That's why we find standard deviation.